Okay, so shut up. So let's pick up where we left off last time and then get into some programming. All right. So last class we introduced C. We kind of talked about this chart here, this history of programming languages, and we were going down the native languages here. Then I'll quickly go down the web languages today. We started off with C, which was a procedural language, the type of language that predated our object-oriented languages today. That was the telephone that looks like a bunch of wires. C++ let us show that telephone to make it look like it's a telephone by stuffing the wires inside of a box. Java said, hey, C++, while the object-orientedness of it is a great idea, it lets a less experienced programmer get into some trouble. It also makes even experienced programmers type extra stuff that always is the same. So when you type the exact same syntax identically 100% of the time, Java said, hey, why don't we go ahead and put that in there for you so you don't have to type it yourself. So Java did a couple of those things. Java also tried to solve, let's call it the non-problem at the time of platform independence. That is, you write a program once and it'll run on all of the machines, any kind of computer. The idea there being that really it was the Apple people, the Apple gamers that were saying, hey, the software's coming out for PC but not coming out for Mac. Boo-hoo-hoo, why don't you help us out? Sun Microsystems, the maker of Java, was probably more pro-Apple than pro-Microsoft. At that point in time, Microsoft was the big bad wolf. So everybody disliked them. So they kind of threw a bone out there with Java with the idea that, hey, now any software, maybe with an emphasis on games, can come out for any platform that supports the Java virtual machine. The issue with that is that it required Sun Microsystems to write that Java virtual machine, the JVM, for all the different platforms. So there was a JVM for Windows, a JVM for Mac, a JVM for Linux, JVM for your cell phones, yada, yada, yada. And that JVM knew how to run Java code. So that means we were adding one additional translation into the middle there, which slows things down. All right? For normal applications, not a big deal. It's just a little slowdown because, again, we keep coming back to this idea that computers are really, 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 really fast. Right? Okay? I can't emphasize that enough. Whenever we use the word relatively slow, or the phrase relatively slow, unless I hyphenate it, then that's a word. Is that true? Is a hyphenated word still a single word? It's like a monster word. No CS English double majors? I would have never written my book for my dissertation if my wife didn't. I mean, it would have looked like a third grader wrote it. My wife proofread the whole thing. All right, so in any case, we rely today on our computers being really fast, okay? So there are times as software developers, in fact, very commonly as software developers, where we will pick a language that might be on the surface relatively slow because it is the best tool for solving the job at hand, and speed, blazing speed, isn't our main focus. Maybe it is. I mean, I think I may have given. I tell you about the project this last week from a PhD student at Marquette for chemistry. He needed this script written for his. He's not a friend of mine, but he's a friend of mine. And he needed this script written for his dissertation thingy. Now I could have sat there and written a C++ program that was very, very, very quick and did all this crazy stuff. All he needed was an input document being translated from direct coordinates to Cartesian coordinates. And the document was in a very specific format. So while I was watching Netflix, I used Python, read it in, converted it, wrote it out, sent him the script back. Maybe took 45 minutes or something to write, where in C++ it would have taken a lot longer. I would have had to specifically compiled it for whatever architecture he was running the script on. Where with the Python program, I just had to make sure he was running Python on the server and he was running everything on Linux, which has Python pre-installed. Here's the script, run it, worked. Okay? Not the fastest script in the world because it's written in Python and Python's an interpreted language. But who cares? I'm translating one text document into another text document. And then he's doing it through his supercomputer thingy that, I don't know, makes bombs or something. I don't know what it's doing. I don't know what he's doing. He's doing something in biochem. So I didn't even understand half the format. He just said, look, these are the molecules, or you have this many of these molecules, and here's the formula for conversion. Like, that's all I need. Just give me the formula. Okay, so really put an emphasis on this idea that speed isn't always the most important thing. Okay? So having said that, Java was not a waste. In fact, if you look at like the highest paying top programming languages to learn today, your big three are probably, at the top, it's probably Python, Java, depending on the week, flipping back and forth. And that has more to do with data science kind of and some artificial intelligence stuff being a big deal right now. And Python's kind of the cool kid in that category. But Java's right there in terms of the language that's going to give you the most money and give you the most options for finding jobs. And then right there knocking on the door is going to be like a C#. C++ is going to be in there in the top 5, and I don't know what I doubt it would be C. Maybe some of these web technologies, maybe like a Node.js or something like that, might round out the top 5 or something like that. But in any case, several of our most popular languages today are not the fastest blazing languages out there. Okay, but I think I used the example last time with Java. In the investment world, Java's revolutionized that, because now if you're a stock investor, a lot of these guys are like day traders, right? Where they either make zillions of dollars, they lose everything. One of the two. But they sit in front of a web browser and launch this entire real-time day trading application out of their web browser. That's all written in Java. It's a Java applet launches because Java is the perfect delivery tool for that. Okay, so great language, but did make a couple of missteps. Okay, we mentioned last time that Java had this little bit of a, let's say, a misunderstanding with structs versus classes. We were talking about objects last time, and the idea is that in any language I can think of, a class is always passed by reference. You get a pointer to where that guy lives in memory. And a struct is always passed by, apparently they didn't fix this guy yet, and a struct is always passed by value. You get a copy of it. Okay. Java's perception on this is that, oh, well, we'll get rid of structs because you can accomplish the same thing as a struct by writing a class and just not putting functions inside of it. Okay, go ahead.
So why didn't they fix those issues with updates that came out?
Because it's part of the innate structure of the language. Yeah, this is less of a feature and more of, I mean, when you take the 470 class in several years when we write a programming language, there's kind of an underlying parser for the syntax of the language. Not that you can't change something in there, but it might be one of the last things you'd want to change. Because at that point, you are fundamentally changing how the programmer works. They probably, now to your point, they could have hacked it. But then all of a sudden it becomes almost another misdirection for the programmer. They could have looked at any time somebody defined a class. If they chose not to put methods in there, they can choose to treat it as a struct. So instead of letting a Java programmer ever actually write a struct themselves, it would just convert to behaving like a struct in the event that it didn't have functions. That might be even more misleading to the Java programmers who did understand the caveat and would. There are some things built into Java for fixing this, like when you pass a class to something else, if you want it to act like it was passed by value, you can call a clone function on the class, which just kind of duplicates the memory, and then it's as if it was passed by value. So I think the idea would be that the people that actually knew what was going on could fix it themselves, and the other people, you just better hope that they don't treat it chances are they wouldn't have known that structs worked a certain way in an older language. Because I kind of mentioned last time, one of the maybe weaknesses in, I don't know, let's call it cross-training programming today is, I mean, obviously computers are, I mean, this generation has been working with computers their entire life, right? Or my generation didn't. We didn't have computers in the very, very early days. So lots and lots and lots of people have at least dabbled in some programming of some level today. Well, what ends up happening then is you tend to use the newest, latest, greatest language, which has already fixed a lot of those caveats from years ago. But all those newest, latest, greatest languages are still built on top of that old technology from the late 60s. So you haven't seen some of those new little nuances. It's almost like ignorance is bliss. You know, who needs a struct? I'm not really bothered by the fact that structs don't work the way they used to because I didn't used to use them. It wasn't an issue. But where it might come into a problem is if you're using, I mean, we've also as a society become very reliant on Google, right? So I'll actually use this opportunity to tell you something. I fully expect a lot of you when you're doing your homework and stuff like that to look stuff up on Google and that kind of crap. I get it. Remember, programming is kind of like a sport. You got to put in the reps. I don't have a problem with you going looking something up in Google, but two I guess recommendations, strong recommendations. One, never copy and paste code in. Always type it. That way you're at least getting the practice of typing the words. All right, so you kind of know where your mistakes lie and things like that. Because it's going to be super common where you come up and say, well, I wrote the exact same thing you wrote and mine doesn't work. And then I look at it and you didn't quite write the exact same thing. You wrote very close to the exact same thing. Well, programming languages are picky, okay? So make sure you type everything in to at least practice. Also, never try to run a program unless you understand what the code is doing. Does that make sense? So even if you're using somebody else's syntax, try to understand how it works. That'll at least push you in the direction of maybe next time you won't have to use somebody else's syntax. Okay? All right. So in any case, that is kind of Java's big story. Good step forward, had some performance issues, definitely made programmers' lives easier. Still super popular today. It was good enough for Microsoft to try to steal. They tried to steal it, named their product J++, Sun Microsystems sued them. Microsoft lost the lawsuit, then came out with C#. C#, we can call that basically Java with a tiny twist. In fact, you would find that a high percentage of Java programs would compile as C# programs with very, very few changes. Okay? Very few changes. All right, so these languages are extremely similar. Having said that, C# did fix a few of the problems that Java had introduced. They brought back structs. They brought back the special syntax for pointers in the event that you wanted to work with memory directly, that kind of stuff. Okay? Now, over on this side of the world, okay, this is the Apple column. Okay? So, when the iPhone first came out, Objective-C was the core language for this because that had been the core language for all that Apple development before that. So you could just think of the language Objective-C as being an Apple thing. Now, where you see it in the hierarchy here, notice that you have this language from the late 60s, C, being a procedural language. C++ and Objective-C are both object-oriented languages. Now, Apple and Microsoft hated each other at the core. At the hardware level, they dislike each other. Okay? So when Microsoft jumped on the C++ bandwagon with Microsoft Visual C++, Apple could not jump on the same bandwagon. They can't agree with the enemy. Okay, so they jumped on one of the early open source projects called Objective-C. Completely different syntax, still C-based, but out of all these languages up here, Objective-C is probably the one that, at a glance, looks the most intimidating to somebody who's been programming in this column the longest. Once you get into it, you realize it's the same crap. In fact, one of my favorite languages to this day is probably Objective-C. It's actually it almost goes the other direction. I've said Java has removed some stuff to make you type less. Objective-C's kind of approach is make you type more. But it's almost like you're telling a story. When you name your function, it's not just like add nums int a int b. It's like, add two numbers with integer a and integer b, and you're like, writing this whole story out of it. And I don't know, there's something kind of elegant about it. Plus, it shows you a lot of what's happening under the hood, makes you do some of the stuff. So Objective-C became, let's say for a long time it wasn't that popular, because obviously even the Apple fanboys, they want you to believe Apple is super popular and all this stuff. But clearly, in the desktop world, even today, Microsoft has a pretty big majority, right? Microsoft's lost like a lot of their ground now. They went from like 98% of the market to maybe 94% of the market. Something like that, okay, for desktop computing. But on the flip side, Objective-C is now a pretty important language from the perspective of iPhone, because the only two real players in mobile is Apple and Android, Google, right? Okay, so then you have, Android applications are written in Java. iPhone applications were originally written in Objective-C. Now they're written in a language called, you can actually choose between the two of them, but if you're starting a new project today, you're probably writing it in a language called Swift. Now, Swift is the newest of all of these languages here, all right? And Swift has actually kind of gone in a similar direction to, I don't know what Apple did. For a decade or so, I was an iPhone user, and then last year I switched to an Android. I've always had both devices for development, but I switched to carrying an Android on a daily basis. I did a Note 8, now I have a Note 9, and I mean, they're all kind of the same crap. But, the punchline is Apple kind of lost me with their whole Animoji thing. You know what I'm talking about? Like their focus is too much. It seems like their target audience is like 8-year-old princesses. That's not as wrong as it should be, is it? Okay, so this whole emoji thing and stuff, I get it. How many of you have a friend now who speaks only in emojis? Oh my gosh, you block them, right? Especially when they're doing it in person. If you had one of those, where they start doing the facial expression, the emoji, it's like new sign language. It's a thing. I've seen it at like Walmart in the Apple store. Mostly at the Apple store. But in any case, emojis have become fairly popular, right? Now, I've mentioned here that programming syntax is very specific. Swift allows you to name variables using emojis. Yeah. Now, what's actually kind of funny here is, Apple came out with this language, Swift. Now, this is the newest language out of all these. It's been out for about 4 years or so now, give or take. And it's been really popular, let's say, for 2 years on the iPhone side. You don't have people from this side of the world jumping over necessarily, except when I tell you here in a second. But for a long time, if you were doing anything for Apple products, right, writing any software for Apple products, you were writing it in Objective-C. Now, as somebody who wrote a lot of software for iPhone and things like that ever since the App Store first went live, I can tell you from a programmer's perspective, Objective-C is a great language. And I can nearly guarantee you that no Apple programmer was complaining about Objective-C. I can also tell you that Swift does not look like Objective-C. So Apple would have had you believe that, oh, well, we finally came out with a new language to finally make the Apple people get up to date with where things are today and yada, yada, yada. The Apple people weren't complaining. Swift looks like Java. What are they really saying here? They're saying, hey, Android developers, come over to the dark side and write iPhone apps. That's what they're saying. The Apple people, they'll drink whatever Kool-Aid Apple's serving, right? So they'll just jump and say, okay, well, our next project will do Swift, and I can get emojis now, wow. And built into Swift, and this is actually kind of going to your point, why didn't they change Java? When Swift first came out, there was like 30 different ways of doing everything. You can write loops that looked like Java loops. You can write loops that looked like PHP or Perl or Python loops, which have a little bit, different syntax. They basically, it was like a overt effort by Apple to say, we want Swift to feel comfortable for you, no matter what language you're coming from. Okay, and then once people started jumping on the Swift bandwagon, Apple started taking away a couple of those syntaxes. You know, you compile something and say, well, this particular way you're writing this if statement is going to be deprecated soon. So I know you liked it from where you were, but now that you're addicted to our Kool-Aid, we're changing it on you. Go ahead.
Sure, like jailbreaking apps like Cydia written in Objective-C, is that how they're like, I don't know, I just don't get how they can like do all the things that you can do with jailbreaking your phone, but like you can't do that regularly. Like you have to jailbreak to get some of these features.
Well, that has more to do with what Apple locks down in their operating system.
Yeah.
So all of these apps run on top of the operating system from the underlying company, right? So iPhone apps run on top of iOS, and Android apps run on, well, Android apps run on top of Android, which is the name of the operating system. Android is an open source operating system, with the caveat of, since it's open source, most people who have an Android phone, unless it's one of the Pixel phones, is running a bastardized version of Android. All right, it's been Samsunged or Binged or, you know, whatever. So chances, well, not chances are, but there will be plenty of situations where there has been modifications to the operating system, maybe for the better, maybe for the worse, maybe there's some new bugs, whatever, but you're not always dealing with a vanilla version of Android. So while Android devices can be certainly more easily rooted, because the operating system is open source, it's sometimes you'll see situations where you can do something on a Samsung, but you can't do it on Pixel, something like that, because it's taking advantage of some aspect. But being open source, people who are making changes to Android applications, they have full access to the underlying operating system, whether Google intended for them to or not. Where Apple, it's a closed source operating system, so Apple can just lock it down and say, well, here's the 11 things that obviously we are doing in other parts of the operating system, but we're not going to let you do. And that's where you'd have to jailbreak it, where they're actually putting a layer between the app and the operating system for pretending to do some stuff or rewriting portions of the operating system and kind of going around it. Kind of reminds me, not that any of you have ever done this, but if you've ever modified a gaming console. So the fun one was the original Nintendo Wii. A lot of gaming consoles could be hacked to play, obviously, open source, probably foreign games, right? More than likely copied games that were pirated. But you know, the point is that the Wii didn't work as well for that, because they had this copy protection thing that it checked to see whether or not the disc you put in there was an authentic Wii disc. So, does anybody know how Wiis were modified?
I had one, but I don't remember.
Okay. You actually had to open it up, and you would buy this little kit, and it would come with like a little kind of piece of metal thing that you stuck over these two little screws. It was like a template. And they said, put a solder dot here and a solder dot here. So you put a little thing that bridged between two pins on the actual hardware of the Wii. And what that did is it bypassed the check. Every disk is good. So it's essentially an if statement that always comes out to true. That's what they did. Okay, so, you know, and that's kind of a computer science kind of concept. Obviously, for hobbyists only, you should still buy original games only, giving the developers full money for it, because at some point you're going to be the developer on the other side and you're going to wish that you got the full money for what you're writing, right? Okay, so, but punchline is, from a hobbyist perspective, you can modify the hardware and then still run legal games. They'll still work because it's always a true statement, okay? Yeah, so in any case, Swift was kind of an underhanded way of Apple saying, hey, we want all of you other guys that are writing stuff for other platforms to come over here to the dark side. And it was a pretty good ploy, because let's say, as unpopular as Mac application development is, it's more popular today than it probably ever has been, but it's not popular. iOS development, obviously, is very popular. Okay, if you are writing mobile applications, the store to make the most money is the Apple App Store. Still today. The app, if you have two apps that do the same thing on both platforms, it makes more on iOS. there's a lot of things that play into that. Part of it is Apple has a much more stringent acceptance policy for their apps, so you have less kind of garbage apps on the App Store, where if you have an Android device, call it, 3 out of 5 apps are junk that you might download, something like that. The other side to it is somewhere in there, there's probably some truth to how affluent the people who own iOS devices are. Probably the average income might be higher across, on average. Not that, Android's for the poor and Apple's for the rich, but there's probably some measurable statistic in there. Okay? But in any case, you can make the most money if you write for both platforms, not just for one. But if you had to pick one, iOS is probably where you want to be. Okay. Then, over on this side of the equation, and I wrote this last time, all of these guys, we call these web languages, but every one of them is an interpreted, loosely typed, and we say relatively slow language. A lot of times, so at the end of the day, what can you say? We're basically saying we're going to take games off the table here. Unless they're like webby games. Like you probably could write Angry Birds in one of these games. That's not like nobody sits around and says, I'm running Angry Birds at 100 frames a second. Not that, Angry Birds is a fun game. It's made zillions and zillions of dollars, but it's not a performance-based game. It's a, time waster type thing. It's just a different style game, right? But generally speaking, anything that you would call high-end video games, probably off the table over here. Okay, these guys are more for business applications. We could probably start with the idea that's probably a website, but realistically, these guys could also be used for writing mobile applications, and we see a lot of tools out there for writing cross-platform applications. If you want to target iOS and Android, you can actually use a tool that allows you to use one of these languages to develop your apps in HTML5, and then it deploys to both iOS and Android. Probably not writing video games that way, but not every app is a video game. A whole bunch of them are kind of utility, productivity type apps, right? And if you're somebody who wants to target both of those platforms and you don't need to have something crazy custom, maybe a cross-platform tool is a pretty good approach. It's kind of the punchline. Is there a question here? Sorry.
No.
Okay, so punchline for us, nothing wrong with these languages. They're fine. They're good. They have pros and cons. At some point, we'll maybe talk about some of the pros and cons. We're living here in the Python thing. Very, very, very popular language today. It's something that is, like I said, it's in the top 2 most valuable languages you can learn in terms of going and making money. And maybe the 2 areas you'd maybe want to focus on related to that, we say Python, is probably data science and artificial intelligence. And oh, by the way, there's also a web stack for Python if you want to create websites using Python-based technology. All right, so it's, the internet must be down. My document could not be auto-saved. Well, whatever. All right, so in any case, if you're talking about making money today, the sweet spot for Python is right here. Data science and AI. These are big, big, big upcoming things. We're going to be creating a data science major here. If you look at a lot of other schools, they're going to have data science majors, and data science is kind of the bridge between traditional programming and artificial intelligence. And I'll probably actually introduce some concepts in that, if not later this semester, then next semester, but we'll dabble a little bit. But punchline is big time jobs in data science. There's going to be big time jobs in AI moving forward. They're already becoming popular with things like machine learning. So between these 2 things, it's going to be a big deal. Okay? And then also you can do web stuff, which I hate. So too much design. I like 97% programming, 3% design. And I'm just fine with it being a crappy interface, and you hand it to an artist who does 100% design to make it look pretty. Whereas a web developer with some of the newest technologies really becomes about an 85% design, 15% programmer. And it's just, I say I hate it. It's not because it's a poor skill. It's just it's not in my skill set. You know, I'm not an artist, and I get really frustrated trying to make things look pretty, but I code pretty well. So I'd rather live in the syntax world most of the time. All right, so whenever we build Android apps and stuff like that in like 250, you're going to see the amazing interfaces we'll be building. It's going to be just award-winning for like kindergarten and stuff. Okay, so what I want to do here is I want to refer back. So let's dive into some programming stuff. Is this our slide here? Okay, so this comes back to this slide right here, which I've referenced several times already. Hopefully that means that it's pretty important. How do human beings solve problems? We use our memory, we ask questions, we use repetition. 100% of programming languages have facilities for those three things. 100% of programming languages have facilities for those three things. So that means once you've learned computer programming as a skill set, if you could figure out how to accomplish those three things in a brand new language that you just learned today, you can already solve a whole bunch of problems. Now, you're not exposed to the little nuances of the language or some of the built-in libraries that make it like really, really, really good at like specific things that it was kind of built to solve, something like that. But as a general purpose programming language, you could solve all sorts of stuff with that language just knowing how to do these three things. Okay? So what I'm going to do is I'm going to steal this slide. We're going to bring it down here to the bottom. And we're going to say Python. So what I'm actually going to do is I'm going to jump ahead in programming and show you all three of these right off the bat. Then we'll back up and do a deep dive into each individual thing. Okay? So memory we accomplish through conditionals, and in Python this is an if statement. So syntax for an if statement in Python. Actually, I'm not going to put the syntax in here. It'll be easier for me because everybody has a working development environment now, so I'll show you in Atom here in a few minutes. And I'm actually lying here. This does not go conditionals. This goes with asking questions. Memory, this is through variables. Repetition is through loops. All right. Now, 2 out of these 3 things require us to understand a specific concept. And that concept is something called a Boolean expression. Boolean types are values of true and false. Something like that. So if I ask, is it cold outside today? Or if I say, it is cold outside today, you would say, true, it's cold outside today. Okay. If I say, is it sunny outside today? You say, true, it is sunny outside today. If I say, it's raining outside today, you would say, false, not raining outside today. So we all understand the concept of true and false? Yes and no. Comfortable with it, just when we put it into computer speak, true and false seems a little bit like it'd be weird if, somebody walked up to you and say, like, did you get enough, did you get 8 hours of sleep last night? You just reply to them true. Like do that for a day and see how many looks you get. Right? But again, by your junior year, you'll be a robot. But right now, you should still be partially human. All right, so in any case, that's what Boolean values are, true and false. Boolean expressions, this is any expression that boils down to a single value of true or false. I wonder why this, well, I guess we'll just let it roll for now. Okay, so a Boolean expression is any expression that boils down to a single value of true or false. Okay? So now, go back over here. I mentioned in the Python programming language, the way we accomplish memory is through variables. The way we accomplish asking questions is through if statements. The way we accomplish repetition is through something called loops. Let's look at all three of these things written in Python. Okay, so I'll go ahead and open up Atom here. And let me do this. All right, so I'm going to go ahead and I'm going to create a new file in Atom. And I'm going to go ahead and save this file. And I'll just put it on my desktop for right now, just so it's a place I can get to. And we're going to call this guy test.py. So I put a .py on the end of it that lets my system know it's a Python file. Okay. More importantly for us, it lets Atom know it's a Python file. And why is that important? Is because Atom will do all the color coding and auto indenting and all sorts of stuff that you're going to appreciate once you get into Python. Because one truth about Python, go ahead and put it here. So this is a Python truth. Extremely picky about indentation. This is actually a good thing. Beginning programmers often just write this really sloppy looking code where some things are left justified, some things are indented, and you can't decide what goes with which. Python forces you to indent properly so that when you go to a language like Java that is fine with you putting everything on one line if you really wanted to, even though that's not good programming practice, you're already encouraged to have your code formatted in a certain way. Okay, we'll see some examples of this. So, I'm going to create some variables here. Is that a variable in Python? All right, so I'm going to create some variables here. So we're going to say name is equal to Mike. Age is equal to 41, something like that. In fact, let's call this F name. And we'll call this L name. All right, so I've created a variable name F name, set it equal to the string Mike. I've created a variable name L name, set it equal to string Littman. I've created a variable name age, set it equal to the value 41. Okay. Python is a loosely typed language. What that means is when we define variables, we do not have to define the kind of value that lives in that variable. And what does that ultimately mean? It means later on in our program, we can store inside of something that used to be able to hold a string, we can now put a number in there. But this would be a bad example of a variable because now we have a variable named F name, and in reality, variables should have meaningful names. They should kind of tell you what kind of value is stored in there. So if a variable was called F name for first name, we probably expect to hold something that sounds like a first name, okay? Not like the number 17, okay? Unless it's what's the name of the show on Netflix? That has the person with just the name, like number 3 or 5 or something like that. 11. Stranger Things. Right? 11, yeah. See? Aren't you supposed to know this stuff? I was lucky I came up with that. Okay, but in a loosely typed language, we can get away with stuff like this. All right? But proper programming practice should say, if I'm going to create a variable called F name, I probably intend to store first names in there. You probably want to hold values that sound like first names. Okay? So, Python, this is legal, but a bad idea. All right, so now we have some variables. I can go here and I can print out F name. I can print out L name. I can print out age. If I want to print these guys all together, I can say fname concatenated with lname. Maybe we want a little space there in the middle. So this is similar to some of the exercises you've done in the book, right?
Yes.
Okay. So I'm going to go ahead and now we're going to run this. So this kind of shows you what you did on your homework assignment over the weekend. All right, so I created a file and I put a bunch of Python code in that file. I saved the file to my desktop in a file named test.py. Now I'm going to go to my terminal. So if you're on a Mac, you're going to go to terminal. If you're on a PC, it'll be what's called Cygwin. Is that what it was called? The terminal installed. So you'll open up that terminal guy. All right, so I'm going to go ahead and move to my desktop. And if I type ls, it's going to show me everything that's on my desktop. If I say ls star.py, it'll show me just the Python stuff that's on my desktop. So this is actually the Unix command prompt. All right, so a little bit more powerful than DOS. So ls is kind of like the equivalent of the DOS dir command for a directory listing, that kind of stuff. All right, but now when I go to run my program, I'm going to say Python, and then the name of my program was test.py, and there's the output of my program. So there's fname being printed, lname being printed, age being printed, and then fname plus a space plus lname being printed. Now keep in mind, if I go back in here, I'm just going to take out these print statements. Is this still a Python program?
Yes.
Sure. Does it still do real things? Yeah, it creates 3 variables and stores values in them. But when I go, and I had to save that, when I go to run that program again, it has no output because my program does not have output. I've created 3 places in memory to hold some stuff and then never used them. Okay? So, perfectly legitimate Python program that does nothing. So we'll come back in here. We'll put our values back. Run this guy again. There's my output. Now, technically, so all of you, when you ran Python, when you installed Python this weekend, you were to install Python 3, right? Now, if I type in which Python here, actually, let me do this. If I say Python -v, is it just -- version? Yeah, Python -- version. What I'm actually running there is Python 2.7. Okay? If you, and I mentioned this in the homework, your Mac, if you have a Mac, comes pre-installed with Python. But the version of Python it comes pre-installed with is Python 2.7, which you just saw actually worked for very, very, very simple Python stuff. But once we get into some more advanced things in Python, the syntax between Python 2.7 and Python 3 changes. So you'll have things that will not work. Okay? Now, you might say, well, why doesn't everybody use Python 3? Well, Python's been out for a long time. And lots and lots and lots of people have big code bases written in Python 2.7, including Google. Google was a Python shop for a long time because they hated Microsoft. Makes sense. All right, so punchline there would be that when Python was updated to Python 3, so usually when you look at the naming convention for the version of a software, the first number is the major version. The next number is, let's call it a semi-major version within a major version. This third one is a small update. So the next thing for 2.7 will be 2.7.11, although there's probably actually already a 0.11. I'm probably not completely up to date on 2.7. Okay, and you'll notice this when you update your operating system for Windows or for the Mac OS. Like Mac OS, it's currently 10.11.4 or something like that. The next little update will be 0.5. Next major update will be, 10.12. That'll be the next thing they name after some mountain or island or something like that. Okay, so on my machine, I install Python 3 next to Python 2. So for me, I have an executable called Python 3, which is Python 3.6.4. Okay, so when you see me run my code, I'll always run it with Python 3 in here unless I forget. Okay, but then when I get an error, I'll switch. All right, but you'll see me type in Python 3. If you're a Mac user, chances are you probably also have a Python 3 because you probably set it up next to your existing one. If you didn't, if you overwrote it, then you'll just say Python, and that will be Python 3. Whatever you do, when you type in your command followed by dash dash version and press enter, you should see 3.6 point something. Okay? Because you want Python 3. All right? So, having said that, for you, those of you who are on Windows where Python does not come pre-installed, and you went and installed the Python 3 version, you probably can type Python dash dash version and get 3.6 point whatever. That makes sense? If you're on Mac, when you install Python 3, it'll give you an executable called Python 3 because it'll notice that Python 2.7 is already installed. Okay? That makes sense? All right, so in our last 2 minutes here, let me just show you the rest of those 3 things. Remembering stuff, asking questions, repetition. All right, so we have remembering stuff up here, proving that we remembered it down here, right? Now we're going to ask a question. If age is greater than or equal to 21, then we'll print out, let's hit the bar. Else, let's hit the arcade. Something like that. Right now, age is 41. If I go and run this, oh, sorry. It says, let's hit the bar, because I'm older than 21. If I go into my code and I change the age to 20, run the same program again, now it says, let's hit the arcade. It allows me to ask a question. If a certain thing is true, if this Boolean expression is true, do this stuff. Otherwise, do this stuff. Make sense? Lastly, loops. So if I want to just count from 1 to 10, I can say for I in range 1, comma, I'm going to say 11, because it goes from this number to this number non-inclusive. So this will go from 1 to 10, not including 11. And then I'll say print I. This will print out the numbers between 1 and 10. Doing something a bunch of times. Repetition. Okay, we have another loop here. So let's say for I, actually let's go this route. While age is greater than or equal to 0, print age is equal to age minus 1. So right now I started age off at 41. This guy right here is going to keep going as long as age is still bigger than 0 or equal to 0. I'll print out 41. 41 becomes 40. Spin back up. Is 40 still greater than or equal to 0? Yep. Counting my age down to 0. So there's 41, then 40, then 39, blah, 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 blah. Finally here, when age was 0, we got into that thing and it printed out one last time. Then age became -1. It spun back up. Is -1 greater than or equal to 0? Nope. So this Boolean expression here failed. That makes sense? For your homework, I'll give you another section in the book, but I also want you to hand type this into, I'm going to put it up on Slack, so all you have to get it from Slack. You have to hand type this code into your Python interpreter and run it. Get your fingers used to writing some of these things. Okay? So I'll go into Slack here. And I'll put it in CSC200. Call this guy code from class. All right, so I'll put the assignment up. You have to hand type that code in and get it working. I'll have you submit a screenshot or something like that. I'll put the assignment up. That makes sense what I'm asking you to do? But hand type it. Don't copy and paste it. If you copy and paste it, it'll work, but you're doing yourself a disservice. And I won't know if you copied and pasted it or whatever. But all right. Questions, comments, concerns, bribes? Go ahead.
Is the reason we're using Cygwin on Windows instead of like PowerShell just because Windows doesn't come with Python?
Correct. Yep. So Cygwin gives you a Unix interface. Yep.